So I'm here with my big bucket of water, and I have two different types of rocks. Both of them are igneous rock. Both of them are extrusive, meaning that they cool on the outside of the earth rather than the very slow cooling intrusive igneous rock. So here I have basalt, which is often a type of lava that comes out and cools and hardens on the surface of the bottom of the ocean floor at the mid-ocean ridge. And then I have this pumice stone right over here. And this is generally formed in the explosive eruptions of volcanoes. So these are non-explosive ones. These are explosive. What I'm going to do with them is I'm going to do the same thing. I'm just going to drop them inside of this water, and I'd like to just make a little prediction about what's going to happen. So think in your head what's going to happen with the basalt, and there it is. It sinks like a rock, as they say. It sank right down to the bottom. Now I have the pumice. So let's see what happens with the pumice. Same thing, right? Except no, it doesn't. Because pumice is the only rock that we know of that is actually so not dense. It's less dense than water, so it floats on top of water, just like the way a piece of driftwood would on top, right? Whereas the basalt sinks right down to the bottom. This one does not. So they have very different densities in this case. The pumice rock is very light. It's actually surprisingly light when you hold it in your hand. You're like, oh, wow, that's barely anything. Whereas the basalt has some density to it. You can feel the heaviness of it. And that is one of the major differences between these two different types of rocks.